Before we go build and use WCF Services, let's take a few minutes and review what WCF is. WCF is Windows Communication Foundation, and it provides a unified programming model for building service-oriented applications. And by unified, we mean that there's one model whether you're communicating internally or externally. So whether you're talking to a service that's on a web server on your own network, or you're talking to a service that's being hosted on a web server halfway around the planet, you continue to have a single model. And one of the big benefits of WCF is that the same service can be exposed to clients over multiple protocols. And you can do this without duplicating effort or switching technologies. So in other words, you can talk to a service over TCP on your network and over HTTP when you're talking to the service over the internet. Exact same programming model. You build the service the same way, and switching from talking to one service on TCP to talking to a different service on HTTP is nothing more than pointing to a different machine name and then configuring the service to talk over TCP instead of HTTP, or talking over HTTP instead of TCP. So it's a configuration setting and pointing to a different server. The underlying model doesn't have to change. The code you use to write the service doesn't change, and certainly the code you use to call the service doesn't change. And this is a big benefit to WCF over, say, web services. Web services are only XML over HTTP. That means if you want to call a web service internally, you still have to go over HTTP. With WCF, you could use TCP internally and HTTP externally. Let's look at some of the building blocks of WCF. We talk about services, and a service is nothing more than a collection of operations that you expose to clients so they can execute them. In other words, these are the methods of the service. Get customers. Get customer, you pass a customer ID. Get customer sends back one customer. You call get customers. That method sends back a collection of customers. So the service is the collection of methods that clients can call. There are endpoints. The host application, whether it's a Windows service or a web server, makes the service available by providing endpoints to the clients. And the endpoints are going to include the protocol. So do we talk to this over HTTP, over TCP, etc.? And then the bindings are literally how you communicate. And there's a class for each of the protocols you can use to talk to services. WCF is service-oriented. Clients are passing messages to the service. And so the service needs to specify definitively how you talk to it. That's the role of the service contract. The service contract defines what operations are available and how clients use them. And in WCF, the service contract is going to be an interface. So the interface says this service provides the following methods: get customers, get customer, add customer, delete customer, etc. If you want to call it get customers, here's how you call it. In other words, what's the name of the method, what arguments does it take, and what's it going to return. You bundle all those up into an interface, and that's your service contract. And then in your code, you identify an interface or class as a service contract by attributing it with the service contract attribute. And then each method of the interface that clients can call, you attribute with operation contract. And that lets the runtime know that clients can call this method. Clients and services exchange data. If you're exchanging simple data like strings or integers, there's nothing additional you need to do. But if you're passing classes back and forth, then you need to create a data contract. The data contract is just a description of the data that the client and the service exchange. So you might pass customer classes back and forth. So you'd create the customer class, then you attribute it with data contract so that it can be serialized from a .NET object into XML and back again. And then you identify the members of that class that can be exposed to clients by attributing them with data member. And we'll see all this in the demo, of course. So how do you create a WCF service? Well, you add a project based on the WCF service template. Then you define your interface, you create methods, and you attribute them with operation contract to identify that clients can call them. Then you'll define any classes you need to pass objects back and forth and attribute them with the data contract and data member attributes. And then you need a host. You can host a WCF service in either a website or a Windows service. Web services can only be hosted on a web server, hence the name web service. A WCF service can be hosted on a web server or a Windows service. So you'll create a host project, and then the service and the host can be in the same project, but more typically you'd create the service as a separate assembly and then create the host. Once you have the service up and running, then clients can call it. In your client application, you add a service reference to the WCF service, and then Visual Studio creates a proxy class with methods that map to the service's methods. And if you've used web services before, you're familiar with that. Then to call methods of the service, you call methods of the proxy class, and the .NET runtime then understands how to call the service, get data back from it, and present it to you. So let's go build a WCF service and then call it from a WPF application. Let's create a WPF application that gets customers' information from a WCF service. So I'll create a new application, WPF application, and I'm going to call this Basic WCF Service Demo. Okay, let's put the window aside for the moment, because before we can do anything with the front end, we need to create the service. So I'm going to add a new project to this solution, and I'm going to create my WCF service. So I'll come down into the WCF templates, and there's 4 of them here. The 2 you're going to use most often are the WCF service library and the WCF service application template. If you create a WCF service library, then you're creating a project that contains your service. And when you build it, your service is a DLL. You would then need to create a project to host it. If you want to combine those, then you can use the WCF service application template, which builds in a single project your service and the host. This is fine for development. In production, you'll typically create the service as a separate assembly. That way you could reuse it across multiple hosts or more easily reuse it across multiple machines. But for our purposes here, I'm going to go simple and create the host and service all in one. And I'm going to call this Customers Service. Visual Studio creates a web project. We can see that it has web.config. This is the host project that will host the service, and it's going to be hosted using the ASP.NET Development Server. And then Visual Studio creates these 3 files here, iService1.cs, service1.svc, and service1.svc.cs. iService1 contains the interface which defines the service. The svc.cs file contains the code that implements the service, so that's the code that runs when somebody calls the service. And then service1.svc is the endpoint. This is the URL that clients will call to talk to the service. So the first thing I want to do here is rename these all, because service 1 isn't really illustrative of what this does. So I'm going to rename Service 1 to Customer Service. So my interface will be in iCustomer Service. And then I'm going to rename my class file. Oh, I guess I have to rename the SVC. I'll rename this from Service 1 to Customer Service, which does not rename my class. So I will now rename the class from Service 1 to Customer Service. Okay, now let's look at these. Let's look at the SVC first. Let's view the markup. And this is just instructions to the host as to what the service is and where it is. So the service host directive provides instructions to the host who's hosting the service. The service is the class customer service in the assembly customer service. You can find the code for this in customerservice.svc.cs, and it's written in C# and debug is set to true by default. So if your service and the host are in the same project, this is the markup you would use. Now, just while we're in here, as an aside, let's say I put my service in a separate project and then I added a reference to it from the host. All I would need to do then is identify the assembly. I wouldn't have to talk about where the code was located or what language it was written in. I could just say, here's the service. This assembly, this class, go call it. But because everything's in the same project, then I do need the code behind and the language, and the debug's probably optional. Okay, so the host now knows what to do when somebody calls the service. Let's go define the service. We're going to start with the interface, iCustomer Service, and Visual Studio creates boilerplate code for me here. I'm going to get rid of this and replace it with my code. And I have snippets, WADT01. I want to create a method called getCustomers that returns a list of customers. And so I'm going to need a using in here. I was hoping that the IntelliSense here would tell me that, but it doesn't, so I'll just add the using. System.collections.generic. There we go. It doesn't help me because I haven't defined customer yet. I'll do that next. So anyway, here's my interface called iCustomer Service. How do we know it defines a service? How do I know it's a service contract? Because it's attributed service contract. And I want clients to be able to call the getCustomers method, so I attribute that as operation contract. Now I can have multiple interfaces in my code. I might be using some interfaces internally. If I was, I can add them to this iCustomer Service file. I just wouldn't attribute them as service contract. And I could have methods that are used internally but not exposed to clients. Those could also be in this interface. I just wouldn't attribute them as operation contract. So any method I want clients to be able to call is attributed operation contract. Now, if I'm passing complex data types, then I would need to create a data contract. And in this case, because I'm going to pass instances of the customer object, I need to create a data contract. So let's do that next. Let's get rid of all of this code and define my data contract. ADT02. Alright, so here's my customer class. It's got a customer ID, a company name, a city, and a state. Now, because this is a customer class, I need to attribute it as data contract. The reason I need to do that is the WCF data serializer is responsible for taking .NET objects and serializing them into XML so that they can be passed back to the clients. WCF is XML over HTTP or TCP. It differs from web services in that web services are XML over HTTP using SOAP. WCF services are still XML, they still use SOAP, but they're not limited to HTTP. But you still pass data back and forth using XML. Now the WCF data serializer knows how to serialize simple types into XML, but it doesn't necessarily know how to serialize customer. So let's say I added a second method to this, int get number of customers, and I pass the country. I do not need to tell the data serializer how to take an integer and translate it into XML, or how to take a string and translate it into XML. But I do need to help it understand how to translate a customer object. So I create my class, then I attribute it data contract, and each of the members that are being exposed to the clients are attributed data member. Alright, so now I have my interface. Now I've got the instructions to the clients. What methods can you call? What arguments do they expect? What are you going to get back? And I've made sure that the serializer can send information back in XML. I'm now ready to implement this interface. So I go into the customerservice.svc.cs file, and I create my customer service class, which is going to implement this interface. Again, here's the boilerplate code that Visual Studio creates. Let's get rid of that and add the real code. WADT03. Perfect. So when you call the getCustomers method, we're going to create a new list of customers, and then we're just going to simply create 4 new customers and then send that back. And okay, so here's the getCustomers method. We're going to send back to the client 4 customers. No point in this simple demo in calling a database and making it more complex. So now let's save this. Let's build it. So far, so good. Now let's test it. And just like with a web service, the first thing you do to test is right-click on the SVC file and view in browser. The host, which is the ASP.NET Development Server, starts up. It's hosting the service, and to talk to it, here's the URL, customerservice.svc. And so if you get this test page, that's a very good sign. That means that the host can actually host the service. Doesn't mean your code, your implementation code works, of course, but it at least means that your host can host the service. If you want to look at the WSDL, the web service description language, XML, that's all in here. It's all very interesting. But for our purposes, we'll just stop here. So far, so good. Now, let's call this from the client. So in our WPF client, the first thing we need to do is add a service reference to the WCF service. If we know the address, then we'll enter it here and click Go. Because the service is in the same solution as my client, then I can click Discover. And again, here's that address. And then if I click the plus sign, Visual Studio communicates with the service and downloads metadata. So it shows me the name of the service, the interface, the operations, and I can see that this is indeed the service I want to call. And so I will now give it a namespace and call it Customers WCF Service. And then if I click Advanced, I can do some additional configuring. By default, collections come back as arrays, but because this is a WPF client, I want to say send them back as observable collections. Or actually, when the data comes back, put it in an observable collection. It doesn't come back as an observable collection. It actually comes back to the client as XML. I'm telling the client, take that XML, and when you create a collection, make it an observable collection. Now I click OK, and then I click OK here. And what Visual Studio does is it generates a proxy class. Here's my service reference. That's the namespace. If I drill into here, in the reference.cs file, there is a proxy class that has methods that can call the service. Okay, so now let's build our UI. Here's the main window. Let's write a tiny bit of XAML. I'll change the title to Customers, and I'll tell the window to appear in the center of the screen. And then I need a loaded event. And then I need a UI. I want a list box, and then I want a text block that will display additional information on customers. So I'm going to add a stack panel, and I'm going to add a list box. I'm going to call this list box Customers List Box. Set its height to 250. Set its width. Actually, I don't need a width. Let's just set its margin equal to 10. Let's put a border around it, a black border. And let's say that the display member path is company name. So I want to see the names of companies in the list box, and then when I select a customer, I want to display additional information, so I'm going to handle the selection changed event. That's my list box. And then below the list box, I want a text block. Give it a name, customer text block, and set the margin. There, that's my UI. That's really all I need. Okay, let's go write some code. First thing I'm going to need is a declaration. And then I need some code in the loaded. WADTO5. Okay, so when the window loads, I'm going to create a new instance of this proxy class. Customers WCF Service is the namespace I assigned when I added the service reference, and Customers Service Client is the proxy class. And Customers Service Client has a getCustomers method. And this getCustomers method calls the service and then returns an observable collection of instances of the customer class. So when the window loads, I'm going to call getCustomers, bring back an observable collection of customers, and bind the list box to that. And I've told the list box to display company name. And then when I select a customer, I want to see additional information on that customer. So I'm going to get the selected item, which I know is an instance of the customer class, but in code it's an object. So I cast it to customer, then I display the customer ID, the city, and the state. So now let's run this. What happens is when the window loads, it calls the service, brings back the customer's information, and displays the company names in the list box. And then as I select one of these, I display additional information on it. Now when I called getCustomers, I brought back all of the information on all of the customers. It's a select star from customers. And then I took advantage of the fact that all of the information is local, so I could just read the customer ID, city, and state properties of the customer object. Now I've got 4 customers with 4 properties each. That's not a lot of information. But also, clearly, I wouldn't bring down all of the information on all 10,000 of my customers. I'm not sure I would display 10,000 customers in a list box even. So let's pick a more realistic number. I've got 100 customers that I'm going to display in the list box, but the average user only looks at 3 or 4 at a time. So I wouldn't necessarily bring down all of the information on all 100 customers. On my getCustomers method, just send down the customer ID and the company name, so then I can display only the company names in the list box, and then when I selected a customer, have a different method called getCustomer, which I would pass the customer ID and then bring back the information for just that customer. And in demos later on, that's exactly what we're going to do. But it's the typical trade-off. Do you bring down all of the information in one call, minimize the calls across the wire, but maximize the amount of information in those calls, or minimize the information being sent back and forth, but do more calls? It's the typical trade-off, and I'm sure you know how to think about that. So what we saw in this demo is how to create a simple WCF service and then call it from a WPF application.